Lesson 13, Logic Gates, Not, and, or. Section 13.5. Logic Circuit Design. Let's design a logic circuit that implements the input-output relationship in this truth table. The design criterion is the number of logic gates. The fewer, the better. This equation represents the input-output relationship of the first row. These equations represent the input-output relationships in the corresponding rows. These three equations can be combined using Boolean OR. This is a naive design of a logic circuit that implements this equation. This circuit has 7 logic gates. Let's reduce the number of logic gates. Let's apply the idempotent law to the second term. Then we can apply the distributive law. Lastly, the complement law is applied. This is the resulting logic circuit. It has only 2 logic gates. This is the same truth table. There is another approach to achieve the same goal. From the second row, we have this equation. This is the double negation law. Y bar is replaced with the above equation. Then, De Morgan's theorem is applied. By applying the double negation law, we simplify the equation to require only 2 logic gates. Experiment 13.5. Pause the video, and follow the instructions. This is to confirm that the designed logic circuit matches the input-output relationship in the truth table. These are the results. They were exported from the logic analyzer as a CSV file. The values of x1, x0, and y were either 1 or 0. When x1 and x0 were both 0, y was 1. The rest are as shown in this diagram. This is the pinout of the ADALM2000. The digital input-output pins are used for the outputs of the pattern generator and the inputs of the logic analyzer. We can select which pins to use for the pattern generator or the logic analyzer. This shows an example of the wiring for the experimental circuit. The pins 0 and 1 are used for the outputs of pattern generator. The output voltage of pin 0 is Vx0, and that of pin 1 is Vx1. Pin 8 is used for the input of the logic analyzer. The input voltage at pin 8 is Vy. Note that the output voltages of the pattern generator are 3.2 volts for high, and 0 volt for low. So, we should set the DC supply voltage for the logic ICs to 3.5 volts, instead of 5 volts. Then the logic gates can judge their input voltages in the range from 2.5 to 3.5 volts as high, and from 0 to 1 volt as low. This is a snapshot of scoping. It shows how to set the DC power supply. Pause the video, and follow the instructions. This shows how to set the pattern generator. Pause the video, and follow the instructions. This continues the pattern generator setup. Pause the video, and follow the instructions. This continues the pattern generator setup further. Pause the video, and follow the instructions. This shows how to set the logic analyzer. Pause the video, and follow the instructions. This shows how to export data to a CSV file. Pause the video, and follow the instructions. Exercise 13.5. This is your homework. Pause the video, and solve the problem. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.